hope you are doing well. Today I am here with another video on software project management under software engineering lecture series. Hope you have enjoyed my previous videos too. Today I am going to discuss some aspects of software project management which are very vital for software development of the product. So finally, software project management is basically all about managing a software product development in a variety of ways. So if we look at the goals of software project management, it basically deals with the faster delivery of the product within time and budget. It basically fixes the responsibility of the program or the product manager to deliver the product within budget and within time. So if we look at the responsibilities of a project managers, they are the project planning with cost estimation, scheduling, project staffing, project monitoring and control, software configuration management, risk management, and after all, managerial reports, writing and presentation. Now come to the software cost estimation. This is very important as far as software is concerned because it will determine the overall size of the product, and from the size of the product we can determine its effort, how much effort is required to complete this software. And finally, if effort is there, we can determine the cost which is required to develop particular software. So cost estimation has been done for effort estimations, which will be important to determine the cost of the product, and it will lead to the staff estimation and also the duration of the product or the project which has been under consideration or which has been going to be built for a specific period of time. So cost estimation is very important and it is a very integral part of the software development life cycle. Then we have different approaches to do this cost estimation. We have empirical model, we have heuristic approaches, we have analytical models. So we will one by one we will see what these models are. So as far as the empirical techniques are concerned, they are basically based on some educated guesses based upon your past experiences. But heuristic techniques, they are more appropriate. They basically estimate based on some mathematical models. And as far as analytical techniques are concerned, they are based upon some analytical models. No doubt they are also very vital, but we basically play on to heuristic techniques because they give the optimal results. So if we talk about the empirical size estimation techniques, we have expert judgment. In this we have a guess made by some experts who are expert in their fields, but this type of guesses, they might not prove vital for some kind of projects. If the product size is small, then empirical techniques are best because we will divide the software product into various components like GUI, database, modeling, communication, billing, and appoint a particular expert on each component, which basically give a guess estimate of the product cost. While we have in Delphi Estimation, a team of experts and coordinators are appointed, and each expert will carry out its own estimation. The major difference here is that they do not know each other and they predict based upon some ration of the product. So this particular technique is more appropriate than the previous one. So here the experts can re-estimate. They can never meet each other. Yes, this is very important because they cannot disclose what they are going to estimate. So this technique is far much better than the previous one. Now we will study what the heuristic techniques are. In heuristic, we have a single variable model and multivariable model. In case of a single variable model, we have only one parameter which has been taken as a variable to determine the cost. But in case of a multivariable model, we have more than one variable to determine the cost of the product. So usually we depend upon the multivariable model because it is more efficient and more productive. So if we talk about a multivariable model, we have COCOMO model, which is called constructive cost estimation model, which is given by Boehm. This model is very, very significant, and this model has been followed by the industry standards. So in this model, basically we divide our product in three categories. One is organic, second is semi-detached, and we have embedded. So in the category of organic, we have relatively small groups, small applications, and the working style is well understood by the team. So if we have a very small kind of organization where few people are working, this model is best. Then we have semi-detached, where we have project teams in which experienced as well as inexperienced people are there. This basically model is best suited for the mid-sized companies. And finally, we have the embedded model, in which basically experienced people, they are working on some complex hardware as well as real-time solutions of the applications. So embedded is basically suited for the research-based kind of companies or organizations where product has been inbuilt with some supported hardware. So if we see at the COCOMO model, so basically this product is basically having three kind of categories as we have studied. So they depend upon a line of code, which is an important factor to determine the project time and effort required for the project. So we can calculate the project time here, which is measured in months, and we can also calculate the project effort, which is calculated in programmer months. So we can obtain equations for calculating project time and effort required in all three categories of approaches. So suppose if we want to have a effort and time development approximation, we can take this model as we have two variables A1 and A2. They will be giving the equation for time effort, and we are having two variables B1 and B2, which are giving equation for development time. We can calculate the development effort by using these equations for different set of categories. Like for organic, the effort will be 2.4 times KLOC and multiplied by factor 1.05, and in case of semi-detached, the effort can be calculated as variable 3.0 multiplied by kilo line of codes, and then it has to be multiplied by factor 1.1. So in case of embedded, the factors are 3.6 and 1.2 respectively. So by this way we can estimate the effort required for a project. And the same equations are being applied to calculate the development time. Like here for the organic, development time has been calculated by factor 2.5 multiplied with the effort, which has been calculated in the previous equations, multiplied by 0.38. And in the semi-detached, we calculate the development time by multiplying 2.5 to the effort, which has been calculated earlier, and with a factor of 0.35, and similarly with the embedded one. So here we have seen that we can calculate the effort required and development time for a particular software easily. If we see the graphs of COCOMO model, this is a graph between effort required and the size of the product. You can see we have three curves for different approaches like organic, semi-detached, and embedded. So you can easily find out the effort required for a particular size of product. So here we are seeing that if size of the product will increase, definitely the effort will increase, and it is highest in case of embedded one. Now if we can see the curve of development time, we have development time with the respect of size. Then again we are having different three curves for embedded, semi-detached, and organic type of approaches, and we can easily find out the development time by comparing the size of the product. So now come to the organizational structure, which is very important as far as project management is concerned. We have functional organization. This is an integral part of the staffing, and this should be taken into consideration before we start the project. So we can have functional groups. Functional groups can be of specification for design, for coding, for testing and maintenance. Especially the effort has been put to build groups, functional groups for different category of products or different category of portfolios. What are the advantages of functional organization? First, it will give the specialization to a particular area. We need a particular specialization for a particular development of product. Like in case of design, we required software architects, which are more experienced than a coder. Similar in case of testing, we required software tester, which are more specialized as compared to the development team. So it will give us a particular help to identify the errors as much as earlier as they pre-built in the system. So what are the various team structures here? We have democratic type of teams, we have a chief programmer team, and we have a mixed type of organization. We will see how these teams will work and differ from each other. First, we have a democratic teams. They are basically meant for the small projects running less than 5 to 6 engineers. Mainly the research oriented projects, they are taken into democratic teams. Here you have access to all kind of levels, to all the resources for all the kind of team members. There is no kind of autocratic development. You can talk to each and every peer of the group, and you can share your development with others. So this is a more feasible structure, and it will give a high morale, high job satisfaction to the engineers which are working over there, because you are having freedom to to your work, to your access of resources, and every kind of person which is working on the project feel good. But if you come across with the chief programmer team, they are basically led by senior engineers in a technical leadership group, and they are mostly preferred for the large kind of projects which require a monitoring, continuous channelization of the product. So you basically appoint a team leader, which may be at the level of chief technology officer, CTO, and you have different hierarchical setups for the other peoples in the organization. So if you see democratic or chief programmer team setups, they are kind of having advantages and disadvantages. But sometimes we follow the mixed type of control systems, in which both type of assignments has been taken into account. So if we see at the chief programmer team, we have a setup like one person is at the top, then some people are working under him, and then we have again hierarchical structure in the organization. But if we look at the democratic team structure, you can say we have different kind of access to the resources for all people working under a group. So this is more feasible. And if we can take on to the mixed teams organization, again we have a mixture of democratic as well as the chief programmer team kind of structure. So I think this is more feasible for most of the organization. So let's come to the summary of this particular presentation. So today we have discussed about what software project management is and how it can affect our software product development. We learned about cost estimation technique like empirical techniques, heuristic and analytical. Then we have gone to the empirical techniques of expert judgment and Delphi estimations. Then we finally studied what heuristic techniques are, which are very vital, and we have studied the COCOMO model, which is used to calculate the effort and time required for a particular product. Then at last we come on to the project staff organization, which is also very important, and we have learned about different categories of staff, of organizing staff, because for the product development it is equally vital. So in this kind of structure, we have learned that how we will come up to this software product development with software project management. Hope you have enjoyed my video and you have learned from this video too. You should give feedback for a positive note so that I can improve on my videos. This is very important, and hope you are doing well, you are safe at your home. Have a nice day. We will meet again. Thank you so much.